Deep within the Cygnus constellation sits a star that violates every known rule of astrophysics and planetary motion. Most stars shine with unwavering stability, yet this distant sun periodically loses nearly a quarter of its light. If an Earth-sized planet blocked a star, brightness would drop by a barely measurable fraction of 1%. Something colossal, shadowy, and completely irregular is periodically suffocating the brilliant illumination of this mysterious stellar giant.
Astronomers analyzing deep space datasets were completely stunned by chaotic dips that defied all conventional cosmic models. No normal planet could ever cause such massive, non-periodic light blockages across thousands of days of observational data. The scientific community immediately realized they were staring directly at an unprecedented mystery in modern space exploration. Was it a cataclysmic collision of giant protoplanets, or something constructed by an insanely advanced alien civilization?
The truth behind this cosmic enigma would trigger one of the greatest scientific investigations in human history. Welcome to the perplexing world of KIC 8462852, famously known to the entire world as Tabby star. In 2009, NASA launched the revolutionary Kepler space telescope to hunt for distant Earth-like exoplanets orbiting distant suns. Kepler monitored over 100,000 stars simultaneously, searching for tiny, regular dips in distant starlight signals. When an exoplanet passes directly in front of its parent star, it creates a predictable, symmetrical light dip. These transit signals allow scientists to calculate a planet's precise orbit, physical size, and potential atmospheric composition. For years, Kepler's automated algorithms cataloged thousands of routine exoplanets following perfect clockwork orbits around distant suns. The computer algorithms were specifically programmed to flag smooth, repeating light curves, while ignoring erratic, asymmetrical data points. To catch strange anomalies that computers missed, scientists launched Planet Hunters, an ambitious citizen science crowdsourcing project. Tens of thousands of human volunteers manually inspected raw light curves, searching for patterns artificial intelligence overlooked. In 2011, several eagle-eyed citizen scientists spotted a bizarre light curve that looked unlike anything ever seen. The strange star, located nearly 1,500 light-years away, was immediately brought to astronomer Tabitha Boyajian's attention. Tabitha Boyajian and her research team analyzed the raw data, suspecting a simple telescope hardware or software glitch. Extensive verification confirmed the Kepler spacecraft was functioning flawlessly, proving the strange dimming signals were genuinely real. In March 2011, the star's light suddenly plummeted by an astounding 15% over several consecutive days. Even more bizarrely, in February 2013, the star experienced a massive dip reaching 22% total brightness loss.
If Jupiter crossed in front of our Sun, it would block only 1% of solar light radiation. Whatever was obscuring Tabby star had to be thousands of times larger than the biggest planet ever discovered. Furthermore, the dimming events occurred at completely irregular intervals, shattering standard planetary transit geometry and mathematical laws. The light curves were asymmetrical, sloping gradually downward before plunging steeply and rising back up unexpectedly fast.
Researchers searched historical astronomical photographic plates dating back to 1890 to study the star's long-term behavior. Astronomer Bradley Schaefer discovered that Tabby star had also been slowly dimming overall for over a century. Between 1890 and 1989, the star's baseline brightness faded by approximately 14%, deepening the profound mystery. Scientists were now facing two distinct anomalies: sudden catastrophic dips and a relentless century-long gradual darkening trend.
standard astrophysical theories regarding stellar evolution could not explain a stable main-sequence star behaving so strangely. The scientific community scrambled to propose conventional natural explanations for this unprecedented interstellar light show anomaly. Yet, every traditional natural hypothesis tested seemed to raise far more troubling questions than actual concrete answers. Astrophysicist Jason Wright reviewed the anomalous data and proposed a radical hypothesis that electrified the entire world. He suggested the chaotic light curves matched theoretical predictions for giant artificial megastructures orbiting a distant sun. Legendary physicist Freeman Dyson had hypothesized that hyper-advanced civilizations might construct massive solar collectors around their stars. These theoretical Dyson swarms would capture immense stellar energy, casting gigantic, irregular shadows across interstellar space. Media headlines exploded overnight, speculating that humanity had finally detected physical evidence of an extraterrestrial civilization.
The SETI Institute immediately pointed the powerful Allen Telescope Array toward Tabby's star to search for radio signals. Radio astronomers listened intensely across millions of frequency channels, hunting for artificial narrowband transmissions or technological noise. Simultaneously, optical SETI observatories scanned the distant star system for pulsed laser signals from potential alien communications. After weeks of intense monitoring, SETI detected no artificial radio signals or laser transmissions emanating from the system.
The absence of radio emissions did not disprove megastructures, but it forced scientists to look closer at nature. Alternative natural theories emerged, including a massive swarm of disintegrating giant comets orbiting in an eccentric path. Another hypothesis suggested a recent violent collision between icy protoplanets, unleashing vast clouds of pulverized rocky debris. Scientists also pondered whether ringed planets with trapped Trojan asteroid swarms could explain the non-periodic light dips. Yet comet clouds and planetary collisions required highly improbable, precise coincidences to match all observed light data. To solve the riddle definitively, astronomers needed to observe a live dimming event using ground and space observatories. In 2016, Tabitha Boyajian launched a record-breaking Kickstarter campaign to secure continuous telescope observation time worldwide. Thousands of citizen scientists and professional observatories stood on high alert, waiting for the star to dim again.
In May 2017, the star finally began to dip again, triggering an immediate global observational mobilization effort. Ground-based telescopes and space observatories like Swift and Spitzer targeted Tabby's star across multiple light wavelengths. Observing the star simultaneously in ultraviolet, optical, and infrared light held the key to unlocking the true material. Solid opaque objects, like artificial Dyson swarm panels, block all wavelengths of light equally across the spectrum. However, microscopic dust particles block shorter blue light waves much more effectively than longer infrared light waves. The multi-wavelength data revealed that blue light was blocked significantly more than infrared light during the event. This crucial spectral signature definitively proved that the blocking material was composed of microscopic, translucent dust grains. The alien megastructure hypothesis was officially ruled out, revealing a breathtakingly complex natural phenomenon at work instead. Scientists now theorize that a melting, tidally disrupted icy moon or planetoid created this enormous dust cloud. As a giant planet was pulled toward the star, its outer icy moons were ripped apart by tidal forces. The shredded moon remnants vaporized, forming an expanding, uneven cloud of fine dust orbiting high above the star. Radiation pressure and stellar winds constantly blow this microscopic dust away, creating constantly shifting, irregular shadows. The century-long fading trend may be explained by slow orbital precession of a vast circumstellar debris disk.
Tabby's star has pushed the boundaries of astrophysics, demonstrating how much we still have to learn about solar systems. It reminds us that nature's creative power often constructs phenomena far stranger than our most imaginative science fiction. As telescopes like James Webb probe deeper into space, similar anomalous stars will surely challenge our understanding again. The universe remains a boundless canvas of unexplained wonders, waiting quietly for curious minds to uncover their secrets. Tabby's star will forever stand as a testament to human curiosity and our relentless pursuit of cosmic truth.